Alright. Hello, hello. Another day, another compiler stream. Looks like I'm actually on track to do the daily first thing today, which is a nice step up from yesterday because that timing was a little bit awkward. So, yeah, I guess I'll just get straight into it. It looks like it has, in fact, refreshed. Ooh, okay. Okay, we got another easy today. I'm probably gonna spend another half hour on this again for average washed related reasons, but you know, so it goes. A good integer. I feel like I've done this problem before. I guess a lot of random problems just call numbers good for some reason. I don't really know why, but I guess, yeah. It's good if it's a substring of num with length 3, consists of only one unique digit. Okay. Okay, this makes enough sense to me. Yeah, so all the digits are the same. So I guess we can, this is just like, this is pretty cut and dry. I think I could do this quickly. Oh, what's the length cap? Okay. We can be a little bit less aggressive about error checking, it looks like. Size. And then we skip. We go back 2 characters, actually. So then we can pull out each substring. No, there's probably a faster way to do this. Let's just start with the brute force way. This might be the easiest way to start. Hey Janine, how's it going? Let's bolt through this problem. I keep forgetting to put the brackets around this. I don't know why. Okay, I thought it'd be a good idea to have music, but it turns out it is not. So we're actually just gonna fish up Spotify real quick and then pause it. It's annoying me at least. So whoopsie. Where was I? Um. Oh, right. So we do that, and then return. Let's see if this works. Let's see if this works. There's a very good chance. Okay, so it doesn't let me do that actually. Let's make this a string instead. Oh wait, this doesn't make sense. Forgot to increment. What is happening? What? Oh, num. Let's try that again. It keeps happening. Okay, surely we're out of errors. Oh no. Oh no. Oh no. Okay. Num of max. We could even just do it like this. And then we can get rid of this even. We can just build the string once, hopefully. Let's do that. Oh. Wait, what? This seems wrong. Okay, why is this? Something is very much wrong with my logic here. I'm not sure what's going wrong. I don't get it. Why is that out of bounds? Where am I getting 55 from? I just washed. What is happening? Okay, so that's not supposed to be happening. Let's just build the string. Does it let me do this? No, it doesn't. Okay. That's a little bit annoying. I was kind of hoping that it would let me do this. But one can hope, I suppose. Uh Okay, we're really struggling here. Does this work? No, no, it doesn't. This is some really insane code I'm writing here. Okay, well, it's printing things now. It's not printing correct things, but it's definitely printing things now. Uh, what is happening? Let's do -1. Let's, none, we return that. Uh, what? Oh, okay. There's got to be a better way to do this. There has to be a better way. Hmm. Let's nuke this and let's start from scratch. Okay. So I want to iterate through each character and only check if it's larger. Um. ASCII table. If zero's at the end, we're gonna have okay, think fuck. Zero's on the correct side, it appears. Let's see if that works. Actually, I should check this. Uh, is there a way I can like? Let's do this. What's like a default value here? Let's just use the space. So if num I is the same as num of I plus 1, can I chain equals like this? Chain equality operator. Ugh, okay, that doesn't work. That's really annoying. So if these are all the same, and let's just and what other conditions do we need here? And then either max car equals blank or num of I is greater than max char. Num of I. NumPy? Like the Python library? NumPy? And then anyway, and then we build the result. Let's see if there's a way to do this. Append exists? Okay. Okay, there's actually a better way to do this. Apparently. Can I just return this directly? Okay, I guess I can't return that like that. Wait, did I get lied to? String, aha, I forgot. Actually, can I just empty string here instead? Change 2 words. Let's give this another try. Oh, I'm stupid. Oh, I'm stupid. Surely this works. What? What? All right, we're just fighting with the string now. Okay, well, this is doing what we want it to now. Okay, so we can do max char equals this space, then we do this, and then otherwise we do that. Ternary operator. There we go. Yeah. Oh yeah. I get to show the really cool syntactic sugar here again. So if we look at this if statement, this is a complete mess, and it's really annoying to like reorder things because you have to like deal with trailing ands. So the initial idea to like make this more readable is just to move all of these onto new line each. So then at least they're separated by line. But the problem with this is that then it's really annoying to reorder. And then if we go over here, even if we pull it out like this, and then we indent these over, you'll notice like we can reorder these two easily, but we can't actually reorder this top line because it's attached to this if line. And it also lacks the prepended double and. So the solution, or the way to get around this, is you prepend it with a true, and then you can move this to a new line. And then that makes it easy to rearrange these a little bit more. So then we can move these as we see fit. Anyway, a little bit of a flex. And submit it. Okay, constant runtime, we're up. We're so up. This is a little bit gross, but yeah, it does run. And then I need to flex on people, so I will send this somewhere. Let's see, what problem is this again? This is 2264. Largest same digit number in string. I'm hijacking a friend's Discord server to post this for reference. And you should honestly check out his channel if you haven't. His name is Aiden Lee, and he makes really good content. And he has been doing this streaming every day thing for way longer than I have. And he told me I should do it, so then I proceeded to do it. So you should give him a follow if you haven't. Oh lord, wait. That doesn't do what I wanted to. Wait. There's an or in here. Wait. I have to escape character this? Ah, that's really gross. Ew. Wait, Discord is not spoilering this out properly. This is really annoying, actually. Does this run if I literally replace this with or? Is this a thing? Is this a thing or am I tripping? Wait, it is a thing? Okay, sure. You know what? We'll take it. I did not know that existed. Anyway, that's the LeetCode daily. Let me put this on my personal little tracker as well. I'm trying to not leak my entire Notion again, because that would be a little bit suboptimal. Okay, now we can move this here. This goes here, actually. Yeah, here. Let's see what other people have done real quick, just so this is about right. People can't be saying this is faster when there's two-string conversions. Or wait. Yeah, people can't be saying this is faster. This seems a little insane. See what other people are saying. Oh, using a set is actually pretty smart. I quite like that, actually. Interesting. Okay. Me personally, I did it in like the more insane way, but you know, as it goes. Let's get rid of the daily question appending. Here we are. What? How do we even categorize this? This solution seems a little bit slow to me. This is just indexing, huh? It's an easy. This is an easy. Of course, it's an easy. And then we pull the name. Okay. All right, neat. So that's the LeetCode done, and actually a reasonable amount of time this time. Yippee. Yeah. Okay. So anyways, what were we working on? Kaleidoscope. Kaleidoscope LVM. Let's see, kaleidoscope. Okay. So last time, last time we were working on, we completed the lecture, So we haven't actually tested it, but it has everything we need from it at least. So yeah. The next step in here after the lexer is the parser and AST. Um, so if you think about what the lexer does, it it takes the file and turns it into, or I guess chunks it into quote unquote words. Um, and I guess the term of art for this is tokens. What the parser does is it reads the tokens and then or it takes the tokens and then based on what the tokens are, or I guess it interprets the tokens more concretely. So it would understand um a number token as its literal value, or an it would understand an identifier as like a variable name, for instance. So um and then the way that the parser stores all of this information is instead of like in a program where if we look let's look here at the example. So instead of this program as just like a literal sequential sequence of tokens, it stores the parsed language um as a memory representation because text sucks to work with. And it's stored in specifically a tree structure, which is where abstract syntax tree comes from. Um yeah, so we make one object for each construct in the language, and it should closely model the language. Um, yeah. So even just like a more concrete example, before we get into this, if we go to, uh, if we go to my personal compiler, and then we go to the front end, I have an abstract syntax tree here. So we have, I guess this file's a little bit easier to read. So we have an object that defines what a function is, and it has a type, it has a name, and it has a body. And a body is a scope object, which is like a pair of these braces, for instance, that I have like highlighted. And then multiple functions make up a program, since the program is just a list of functions in this, for instance. And then the rest of this is other stuff that doesn't particularly matter here. But a more concrete example of the instructions here. So we have a scope, which is a list of instructions, and then you have other example instructions. This is a really small subset of C right now because I haven't gotten a lot done. But for instance, um, yeah, so this is like a C program. This just has a return instruction, and as you can see here, it returns whatever E is, which doesn't exist, but that's a future problem. So yeah, it stores what E is in value, and then yeah, that is the memory representation. So for example, if we let's go to the test directory. Let's change the makefile real quick. Let's do the one-line test program that I showed before. Test one line. Then make AST. It used to it used to print out like a sort of like literal tree form of what it parsed, but I made it look a little bit prettier now. Actually, we can just make, yeah, as an example. So yeah, it understood that there was a return instruction inside, and then it pointed it to whatever E here lives. And this is a little bit abstract, but yeah, that's like the general idea. All you need to know is the AST is sort of instead of having a human readable form of the program, it is sort of like a binary-ish representation. That's definitely like not a very clean explanation, but that is like it is just a representation of the program in memory rather than just the human readable form. So parser. Ooh, that's a pretty icon. Anyway. Yeah, please do not clip that section. That explanation is a complete mess. That's not very suitable for human consumption. Let me make everything larger, actually. This will be helpful. Okay. Yeah, so we build a parser and we build an AST. So, yeah. So we want one object for each construct. We have expressions, prototype, and a function. So notice how these are like more distinct names for, I guess, the specific tokens rather than the token which describes just what something is. So expr number expr. Okay. Yeah. Let's make an AST here. It just occurred to me, maybe I should have written my AST with expressions. That might have been a good idea. I really should have done that. That's a future project for me, I guess. Let me put it on a sticky note real quick before I forget. Because that is actually like genuinely a really good idea for something that I should do, or a change I should make. Yeah. Okay. Class number AST. Okay, so we have like dynamic dispatch for this. So we only create the AST for now. Okay, yeah. So we're literally just adding all the structures to it. Prototype. What is a prototype? Do y'all know what a prototype is? I don't know what a prototype is. Oh, I see what a prototype is. Okay. This makes sense now. Okay, great. So let's make this a thing. Let's just split screen this so it's a little bit less messy. This is for the dynamic dispatch for destructor. number expressed. That extends exper est. Oh, what was I doing? Let's clear harpoon. Let's add this to harpoon. This as well. We need to include ist.h. This doesn't need that. Val, and then that. Actually, we could even just one line this. I don't need to reinvent the wheel here. Okay. So now we add the rest of these. So variables exist. Binary variable expressions exist. Binary operations exist. And then function calls exist. These are all just kind of data structure-y, it looks like. So yeah. Refreshed my YouTube page. Sorry. Yeah, we can actually just copy this. Then 3 copies of it. Number, this one will be variable exper. So it's gonna be a string reference name. And we need to include string. And that has a name. This one is binary exper. And then this one's a little bit more annoying. Ooh, we have unique pointers now. Okay. So we have an operator, and we're using unique putters to left-hand side, left and right, I guess. Where does unique pointer exist? Memory. That's where that lives. This constructor has op. This type is a little bit unwieldy, but it'll do. This should go on a line break. There we go. Much better. Not really. This is not at all better. This might just be kind of doomed from what I'm reading. What's wrong with your? I forgot to add a semicolon. Okay. Now this last one is call. Call expir. This one's also call. This takes. This takes a callie and then. Oh no. The vector of the unique footer. Okay, so it takes args, and I need to include vector. Okay, and this seems like pretty boilerplate in general. Let's make these all things now. Let's see. Let's steal all these. Add them here. Let's get rid of all the other stuff that we had left over. Oh wait, I need to. It just occurred to me I need to do this. These are getting quite long, so we're gonna move these to new line. Name. I don't really know what the prettiest way to do this is. I guess still new line it. Op. They're the ops. I have problems. Anyways. Zoom out once so it's a little bit more bearable. Callie is callie. Args is args. Okay, what's wrong here? Deleted constructor? What? Stood move? Okay, wait, I need to learn about unique pointer. This is a little side tangent. Unique critter. I tried learning about this when I was working on my own compiler, but then I got lazy and decided just to use standard pointers and call it a day because I was quite lazy. Okay, let's zoom in. Stood unique pointer is a smart pointer that is responsible for and manages another object. Okay. Okay. Okay, so um this is like single ownership. It which I guess makes sense because it's unique footer, but yeah. Okay, that makes sense. So that explains why stood move is necessary, because then we're transferring ownership, right? Is that what move does? I really hope that's what move does. Move. Oh wait, no, move literally move. Okay, yeah, move literally moves it. Okay, so here we do need stood move. And then stood move. Uh, let's see, where's my surround? I'd very much like to get more used to using surround. If I feel so slow just doing this by hand. Is there a visual mode version? So delete surround, change surround, and then U surround, I guess. Okay, so GS. G surround brackets? That's not... Okay, let's just go to the surround, mini surround. This is the NeoVim plugin I use for, I guess, adding and removing surround. Let's just... mini surround without spaces. Closing bracket. Surround word with closing bracket. There we go. Okay. I'm learning. Stood move. I guess I shouldn't need to do it with visual mode anyway. Okay, that's quite nice actually. I don't know how I didn't know that. Seemed pretty basic. Okay, where were we? That's unique footer. Okay. Here we are. So these are all the expressions, it looks like. So now we get to rules capture variable name, binary operators capture opcode, let's capture function name, as well as args. So these are all the expression nodes. Now we need to interface the way to interface to a function and a way to describe functions. So type is just a count of the arguments. Right, because they're all doubles, so I guess type is a little bit silly. Yeah, so expressed would probably have a type. Yeah, that makes sense. That actually makes a lot of sense. Maybe I should rewrite my own AST to be like this. Okay. Hmm. So just comparing this against the language. It's like this is proto. And I guess this. No. I guess it'll be reused. So we'll figure it out when we get there. Um, so let's add the header. I don't really get why this exists yet, but we'll find out soon enough, I guess. So we need the name, and then we need a vector of args, public. This has that constructor's ugly. I'm really used to putting the ampersand and the star for pointer slash reference on the type, but I recently learned that that's not good. Um, and that's yeah, it made sense in my head previously because I because like it is a string pointer or a string reference. And then I learned there's some things that just physically break. So, um, yeah, I do need to do it this way, unfortunately. But yeah, I'll get used to it, I guess. That's something that I will just have to deal with. Um, yeah. So it needs a name, and then args. Right, yeah. I would probably want to break this into a separate line. And get name. Okay, sure. Sure. Do any of these other ones have getters? No, no, no. No? Okay. Alright. We don't enjoy getters out here. The const reference to string. I don't understand the consts. What do these consts do? So the return parameter is const, and after is okay. So the return thing is const, and the function itself is const. Okay, that makes sense. Okay, neat. Neat. Right. What's next? Function AST. Anything there? Yeah, there is. I forgot to semicolon that. It's private fields. Okay. It's unique footer. Unique footer to the body. This signature is gonna be a little ugly. There we go. Neat. Now we have to do the fun thing. So let's take these out of their head, the class declarations. And then let's start implementing these. Prototype S. What else do I need here? I need to set name to name, args to args. And get name should be pretty straightforward. Looks pretty sick, gamer. Thank you. Where does this and go? Appreciate it. Let's go here. Let's ask Gemini. Josh says I'm embarrassing you. No. It's good content. Wait, this doesn't answer my question. Does this attach to this mess or does it attach to string? Wait, what? This... Okay, so this doesn't answer my question, once again. We're just gonna do it this way because it's consistent and call it a day. this here. What did I do? Okay, there we go. What else did I put in here? Oh yeah, no, I have brain damage. There we go. Oh, I can't do that. I have to surround the word with braces, stood, move. There's some other small thing that I wanted to try actually that I just thought of. Speaking of which, what's it called? Vim difficult plugin. Vim NeoVim hard mode. Hard time. That's what it's called. Okay, let's have some fun with this because I need to get better at motions. So let's just go to dot files. And then this goes into coding, I guess. Not. Where does this go? None of these really make sense. Editor, I guess? No, this is about like appearance. Let's do hard. Let's just make a separate hard time. Does this include everything? Yeah, it does. Okay. Neat. How do I add a plugin again? Return. Oh, that doesn't work. There we go, I think. Oh, wait, no, this is not. Wait. Like this? Is this what I'm supposed to do? There we go. First try. Set show mode to false. Yeah, let's just give this a try. Okay. All right, this is gonna be fun. So, what this does is, if I do something slow, it yells at me. That is all this does. That is literally all this one plugin does. So, we're gonna have some fun with this. Yeah, like that. And it literally stops me from spamming. I'm spamming the K key right now, and it just stops me in. It literally stops me in place. So, yeah, this is gonna be funny. We get to learn how slow I am at writing code with this editor. Also, it like turns off the mouse, which is also quite important. What? Where am I? There we go. Okay. Where was I before I got sidetracked? Parser basics. So we should define the parser code. So we have a bunch of words now, and we have a place to put the words with their meanings. Or I guess we have a place to put sentences. Now we need to turn the words into sentences, pretty much. So parse this. Okay, that makes sense. Is this all I need here? I think that's all I need. So now we go to parser. Pragma once. Did I pragma once this thing? I did, okay. Actually, I can get rid of these two. Okay, there we go. Is this how I did this? In here? Not AST, Lexer. Yeah, I defined a class. Wow, I'm slow. Public. Oh, wait, okay. So there's a private field named current token. It's, not static. What did I do? There we go. I pasted an empty line instead of creating a new line, which didn't indent. Okay. I guess I could implement this real quick. So int parser next token. Wait, what? This works? Oh, wait, yeah. I need to do this in a different way now. It's already happened. Okay. Wait, so what happens if I just hold it? Okay, it also just blocks me. Okay. Okay, so I need parser that takes in a can I do this? Oh wait, this works? I thought it didn't work. Because this doesn't work. Oh wait, it's in Lexer / Okay. Yeah, we're gonna be a little lazy with this. Because I don't really want to set up CMake lists properly. Yeah, this is all just like boilerplate for the most part, though. This is not the interesting part. Xer. So we need to be able to give it the Lexer. Ah, I'm missing something here. I forgot to do the thing again. I just tried to use the arrow keys again. Wait, does this... Okay, I just fold blocks my arrow keys, which is probably a good thing. Laxer. Lexer. Unknown type name? Oh, I forgot to include the header. Okay, this is getting quite annoying quite quickly, which is admittedly the intent. So we're making good progress, it looks like. Talk equals Lexer dot get talk. Get big T. Constructor parser should not return a value. What? Is it? Whoops. There we go. Okay. What else do I have to do here? Okay, so we've gone through there. So we have a token buffer now. Every function will assume that current is the current token. And log error. And then log error p. What is the point of what is the point of this? Oh, this is prototype. I see. Okay. Okay, that makes sense. This means I need to import more headers that I don't remember, which will be funny. This is the header, so we're gonna let's import this because I'm lazy. Unique pointer of x per ast. This needs to include AST. Ugh, I can't spell. This is log error. What? Oh, this takes a... Okay, sure. I need to... What am I doing here? Why do I need a C string? Wait, does it get mad at me if I mass delete? It doesn't? That seems like a massive flaw in the way this is designed. Oh, wait, so this literally has to be a char star. This is gross. I don't like this. I keep hitting... I keep hitting the help key somehow. I don't know how I do it. What does this do? Anyway, that's a little bit annoying, but I'll get used to it, I guess. Okay, I lied. I've done that for forever and I still haven't gotten used to it. Let's implement this real quick. Uh, where does fprintf? C stood IO. Okay. Stood error. Return null pointer. This seems... Uncle Bob would not be happy with this one. I guess Uncle Bob is not happy with C++ as a whole. Oh, I guess this is just a wrapper. That makes sense. Okay, sure. Okay, numeric literals. Simplest to process. Reach production will define a production. Okay, I mean, sure. We'll just call it a production, I guess. For each production, we'll define a function which parses that production. Uh, is this described anywhere? I hope this is described somewhere. Production assistant jobs. 1 second. I still don't know what a production is. I feel like I'm getting caught up on this for some reason. It really should not be that complex. Okay, so parse number. Okay, so we just parse each. Eat. Parse. Let's just parse the stuff. Alright, so then after all this parsing, just so I figure out what's happening. Okay, and then we have one big main loop parser. Okay. I'm just looking ahead. Where's the code gen part? Oh, that is formatted wonderfully. Hmm. Wonderful. Ooh, okay. This will be interesting. Hmm. Okay. Okay, so this is basically just like the literal front end, it looks like. And then what's after this actually? JIT and optimize the support. Okay. It's all this analysis in line with the code. One side and right hand side are the same value. Okay, sure. Uh, ooh, okay. I should look through that again. Ooh, okay. All right. I'm getting quite ahead of myself. Um, Part of me wants to finish this right now. The other part of me is quite hungry and wants to eat dinner. So yeah, I might do that one instead of finishing the parser. Um, yeah, I'll just leave a note for myself here. Yeah. Uh, let's break this into two separate commits. Get push J. It just occurred to me I had a separate window that's supposed to be for terminal. Okay. All right. I think I'm gonna call the stream there. Um, I am quite a hungry individual, so I'm gonna go eat. Bye bye.